Momentum and impulse. Momentum measures how hard it is to stop a moving object. More massive objects have more momentum than smaller objects. Faster objects have more momentum than slower ones. Momentum is a vector quantity, so it has both magnitude and direction. And we calculate it with the equation. We use the letter P, oddly, to stand for momentum. And it is the mass times the velocity. A scalar quantity times a vector, which is how you get your direction at the end. Momentum is either measured in Newton seconds or kilograms times meters per second. Our mass is typically in kilograms. Our velocity can be meters per second, miles per hour. The same as it has been. Contrast that with impulse. Impulse is the change in momentum. So impulse is equal to the change in momentum, or it can be equal to the mass times the change in velocity. Or sometimes you might see that written as mass times delta V. It will have the same units, Newton seconds or kilogram times meters per second. The impulse momentum theorem. Since impulse is equal to the change in momentum is equal to the mass times the change in velocity, because you have a change in velocity, is this sounding familiar? That means we have acceleration. Acceleration is always caused by a force, a push or a pull. Acceleration is caused by a force. Force is equal to the mass times acceleration. So impulse is equal to the change in momentum is equal to force times the change in time.